And once again, welcome to the 2020 webinar series, Nice Equations and Apps to Teach Math Online by Tiet Dong Fan Yamada. The views expressed by the presenter are not necessarily the views of AMATYC. Commercial products mentioned are not endorsed by AMATYC. McGraw-Hill is the sponsor for the 2020 AMATYC webinar series. And as she is pulling up her material, let me give you our introduction. Tiet Dong Fan Yamada is a lecturer at the Math Department, Cal State, Los Angeles. She enjoys building interactive graphical illustrations with GeoGebra to teach statistics, trigonometry, and calculus courses. She has presented much of her work in conference and in journals. One of her papers was featured on the cover of September 2014 AMATYC Journal. Her presentation, Teaching Statistics with GeoGebra, was well received last August in an AMATYC webinar. She's the president-elect of the California Mathematics Council Community Colleges South since March 2018. Just a quick comment about our format today before I turn it over to our speaker. She will take all major questions at the end, but we will also be monitoring the chat if you have questions as we go along. Her presentation is broken up into several sections, and if there are questions specific for each of those sections, we'll pause and have a brief chance to ask questions at that time. Any general questions we will handle at the end. At the end of the webinar, there will be a link to the evaluation of the webinar. Part of that evaluation is where you can get the option to request a certificate for those who want a certificate for their participation today. And with that being said, I will turn it over to you.
Let me join in my screen first. So welcome everyone to, thank you for joining me for today's talk. So in this talk, we're gonna see how to write equations with integer solution for system of linear system equations, rational equation, radical equation, log, triangle, with integer sign and an angle, integer angle. And then go a little bit further for linear algebra, which we do with eigenvalue, eigenvector. And we have time, we take a look at some statistics apps that you can use in your class. So this talk is my work, basically my work I'm using for my class, inspired by one of the speakers in CMCQ South years ago, and then he presents something nice about equations. So I'm thinking, oh, I should write this one for use in my class. And then the app that you see it playing there, that's one of the things that I wrote. So you will have access to all of this today. Okay, so let's go to the first one. So for the system of linear equation, 2 by 2, not bad, but 3 by 3, sometimes it's hard to see the answer right away, and then it's long work. So for the student, I would like to give them some nice number to do. So we can have the system equation like this. So all the coefficient would be integer, and then we want to have the answer would be integer. So the way we do, we start with integer x, y, z, and you multiply with all the coefficient right here, and it come out with answer RST. So that's how you set up that. So with that, then you will have your integer solution x, y, z. And in this way, you can set, I usually set my number like within 10, within the finger. So make a student easy for them to do. Here is the question bank. Pat, could you please like paste the website, that's this one right here, and then you go you follow ifanyamada.whipley.com and you click on teaching and you click on math for elementary school teachers. Let me do this one so you can see here. So you
Okay, so I have the main link to her page in the chat. So if you want to follow along on your own,
yeah,
you've got the link in the chat, and you can go from there. If you want to wait and do this later with the recording, you can certainly do that.
yeah. So you go to my website right here, you click on teaching, and then you click on, I hide it underneath here. So math for elementary middle school teacher right here. You click on that, and then down here is a integer equation with integer solution is right here. So you click on. So you will go to my website right here. So the first one is the solution for system of linear equations. This one have integer solution, and this one have not integer solution. So you can have that one later. But we focus on integer solution. So click on this one. You will see 2 apps in here. So this one is for one solution only. So when you go in here, have the system and they give you the answer right here. So new problem, and then you can have all the things you have in here. And for the second one, this one right here, you have is infinitely many solution. They don't give you solution set, but they let you know this system will have the infinitely many solution. And if you change new problem, you will see new problem right here. And if you choose no solution, so these are questions for no solution. So you can have in here. So you can use this one during while you're teaching. You can give this number real quick for your student. So that's it for system linear equation. So you probably see this before. So not new to you, yeah. Now rational equation, so I have this form right here, 1 over x plus 1 over x minus r equal 1 over b. And for this, you're gonna do denominator and then do all the things so we come up with the quadratic equation in this way. And then using quadratic formula, we have the answer would be in this form right here, just using, negative b and so on, you have right here. Your discriminants, you have this part right here. Now look at the discriminant d equal to square root of a squared plus 4b squared. So this one is some sort of, if I have d squared, that would be equal to a squared and then plus 4b squared. It's like a Pythagorean theorem. So it turned out that if we set up d in at Pythagorean triple, so I have a and then 2b and then d. That would be the Pythagorean triple. Then we will have d would be the integer. Now, not only that, you see that over here, when I plug it back, I have d equal right here. So d like d an odd number. So, and when you plug in, you have there. Notice that if d perfect square, then d and a would be same parity. So that means if a odd, then d odd. If d even, then a even. So then in either way, when we come up with this part right here, so in this case here, we choose this way, then look like a always odd, so d always odd. So then when we simplify this, so we will have the answer over here. Then you will have that could be x would be in this form and another solution right here. If you set up a equal to 2n plus 1 and b equal to n times n plus 1, then you will have the integer solution. So this equation here, you just pick an n for number integer n. So I do n is bigger than 0, so make it easier, because 0, then this one doesn't work right here, and if n equal -1, this one doesn't work right here, so 1 over 0 doesn't work either. So I choose positive, but if you can take out the 0 and -1, then you can choose any number that you want to. You can set up your equation that way. With that, then we will have the question bank right here. You go to rational equation, you will see it's right here, integer solution. So I have 2 apps in here. One of them, this one is have word problem in it. It doesn't have many questions, but like something like this, so you can give it to your student. You have the answer right away, right here. And then anytime you move the slider, then you will have the new problem. For second app, this one here is have only equation only, doesn't have word problem, but you can put whatever you want in here. And the solution will come out this way here. So I have that part. So you change this here, new equation, you will have a whole bunch of equation that you have. Now we go to the next case, that would be the radical equations in this form, square root of x minus a equal to x minus b. And then if I square both sides and then I simplify, so my equation become quadratic equation again. So using quadratic formula, I have my equation like this way, and here it might be discriminant, so you have that part. Simplify this one, you come out something nicer. You have d equal like this. So if I take d squared equal to 1 minus 4 a minus b right here. So if d is perfect square, then d must be an odd number, because this here is 4 right here. So that's an odd number. So therefore, with that observation, so I will let d equal to n minus 1. And then I replace back, my a should be an integer too, because n minus 1 I square, so 1 cancel out, so everything cancel 4, and plus b an integer. So I will have a will be an integer. And then, so from that, my equations x minus a square root of that equal to x minus b will have 2 integer solution. Now, notice that for this equation right here, if x less than b, then this part gonna be negative, so it doesn't work for real number. So you look at here, if I have this one here, b is a number and also integer, so this one guarantee it bigger than b. This one sometime it will less than b, so maybe not an integer. That's it when you be the actioners. Now, if I add a coefficient right here and I play the same game, so then my equation in this form, now my d have more things in here. Again, take a look at here, c and d have same parity. So if c is odd, then d odd, if c even, and d even. So therefore, I would choose my d equal to c minus an even number. So that would have same pair. So I plug it back, I plug it back over here, I solve for a. So a in terms of b, c, d. So given a free number, an integer b, c, and d in terms of n right here, right? B, c, and n, then I will have my a would be in this form, this way. So with that, I plug back over here, then my equation square root of cx minus a equal to b, x minus b, will have 2 integer solutions. And again, we want x have to be bigger than b. So therefore on here, you will see if x is less than b, then it would be an actioner. So you can set up your program that way too. Over here, I have, so that is the summary for that equation I just asked you about that one. Now we can put in general form like this. So I have square root of cx minus a and equal to ex minus b. You use the same trick. You plug it back and you look at that either Pythagorean triple, or you can see some other way to form it up. And then you will have 2 solutions right here. What is b? B is equal to PE and A equal to P Q E square and C equal to Q E square. So you're going to choose, you have the free number P, E, Q, and N. And then you use the, sorry, not N, P, E, and Q. And then you set up C, B, A in this way, then your answer will be an integer. So I have a question bank right here for you to see. It's right here, radical equations. So I have three forms right here. So one of them in the first one, so very nice, just x plus and something like this, and the second one, and the third kind. So I have three of them. So here you can use one to give to your student, or you can program your own using the formula that we have above. Is there. And then now we're going to move to the next equations. I don't know if you guys have any questions so far, anything that you guys want to have, and I can answer you before we move to the next section.
Yeah, I haven't seen any questions yet. Does anyone want to ask a question at this point about that first example? Someone wants to know, can they copy and paste those equations?
Copy and paste, let's see. Yeah, I have a lot. I answer Clifton here. So we have the, I use GeoGebra to teach all the way, you know, calculus up to differential equation too. So it have a lot of that. So you can check out my website, and then you can see a lot of app for all classes, and geometry included too. Geometry, also drag. Yeah, I have a lot of project on that part too. So take a look on that. About the chat, let me see it real quick. This one.
Okay, we got the
yes.
See. Oh, go ahead. Are you seeing the questions? So
I see the questions. So first, yes, P, Q, E, C are integer, right? So you put in there, then you will have that one. So I use that setup to write down my app that you see in there. For the GeoGebra, so when you save it in the animated JPEG, and then it will have that animation. So you will copy that animated JPEG, and then you place it on your algebra. I mean your PowerPoint. Then it will come out moving that way. Yeah. Yeah, I think the screenshot you could have the screenshot is just a picture, but you want to have the animations like the way I do over there. Then use the animated animated JPEG. It's on GeoGebra. They have that one. Okay. Okay.
I think we can move on.
Yes. Okay. So now we go to log. So log is like, usually it's not easy to pop up right away the questions to write. So I have two forms. Form one, I have the equation right here. We see is a positive integer over here, and then equal one in this form. So again, we convert it to quadratic equation this way, and then we use quadratic formula. So we have simplified D in this one again. So notice that you see this here again, we can use a Pythagorean triple. Over here, it doesn't have square, but we can make it to make it work. So over here, so we're gonna have this first one here, A minus B would be equal to this, and 4C equal to the one over here. So we can drop the 4. So I have C equal to this part. So you notice that C require this one C had to be positive. So this one guarantee, if you choose N a positive, then an integer, positive integer, then for sure you have that one. We cannot use the other trick because, you know, if you use the other one, you just set D equal whatever you come out. So sometimes C is negative, then doesn't work. So use the Pythagorean triple is the best way to do this here. Then if you plug this back over here, you will have D equal to this. So these are the formula of Pythagorean triple. So you can look up, I think they post it on the some of the algebra book, they have this one too. And then, so with this setup here, so I have given an A and an N, then I can have my B and my C in this form. So I use that for my number right here. And then, so my equation will have integer solution. So I just plug this back here and then simplify. Then I will have my answer equal to x plus n squared, and then over here. So you can, after this, I post this slideshow on the AMATYC, then you can download and you can verify. So I'm in the process of writing this paper, finalize and submit. So maybe you may see this paper like next year or so. It takes a long time for publish the a paper, so that you can see it's all my reasoning and thought in there. So now we have two answers right here. Notice that x here had to be greater than A, had to be greater than B. Otherwise, you will have you don't have a solution. So therefore, take a look here. So if you have A is an integer, I plus a positive numbers is always positive. So therefore, this one always a solution. And also, I have here the way B set up right here. So B is smaller than A, right? Because A minus a number right here. So therefore, B is always smaller than A. So we will have this one always integer with N is bigger than 0. Now this one here, it will be always be negative. I'm sorry, always less than A. So A and minus a positive number, this would be less than A. So then if it's less than one of these, that is not solution. So you can set up for your student to answer, and this one always a solution, and this one is always an alternate. So you have in there. Now we're gonna move to the form number 2. So this one, it's just like same thing before, but it's equal to right here. So therefore over here, instead of have C before, I have C squared. And then using quadratic formula, so I have D equal this part right here. Simplify some more, and then it come out like this here. So D squared equal to something squared plus something squared. So again, we're gonna use Pythagorean triple. So you see that Pythagorean triple is very powerful, all of this equation. You see most slide I have is use Pythagorean triple in here. So therefore we're gonna use that formula again. So we have A minus B equal to 2n plus 1. So from that, so I can get A alone. So I can have value of A right here. So again, if you have n and a positive number, positive integer, then A over here always bigger than B, right? And over here, I have C equal to a positive number too. Also guarantee this one, guarantee it bigger than 0 for n bigger than 0. Then with this setup, I will have my D equal an integer right here in this form. So I plug it back to the equations right here. Then I will have my answer simplify in this form right here. And again, you notice that this number here is always bigger than B. And it's not just bigger than B, but it's also bigger than A, because A equal to B plus 2n plus 1. This one here have 2n plus 1 here, and then plus n squared. So therefore, this one is for sure it's bigger than A as well. So therefore, this one always the answer. However, this one here, you have B, and then you minus a number, a positive number, so it will be less than B. So this one always an extraness. So you can have that part. So you go here in my question bank in here. So this one you go to logarithmic equation. You click on this. And so you have two equations right here. One of them equal 1 and the other one equal 2. So I list two answer, but one of them an extraness. So you can see that way for over there. So anytime you do new equations, then it have come out. Or you can change this one right here only. Then you see the equation is changed with this one right here. You have that part. Yes. So new equation you can have all new you have in there. So two of them. Will you be able to go to my website too to play around to see if you can get the app? Yes, everyone? Okay. So now I'm gonna move to the next one. It have integer triangle with integer length. So given a triangle with integer length, ABC, and we need to find an angle with the measurement. So have the student to type this one in, radius, radian or degree. Radian is kind of challenge for them to do that well because it's always repeated and have number not repeated is irrational. But some of them nice ones. So the one is nice. We use it come out the 60 degree and 120 degree and 90 degree. Let me pause a little bit so I see a question here in the chat.
Yeah, there's a question. Do they need the GeoGebra app installed on their computer to use these?
No, this app is online for you. Even you can use the phone is work, but the phone, the problem with the phone because it's too small. Some of my app is big. I mean, the size is big. So the phone, it works too, so they don't need to download it. But if you want to programming like the way I do, then you have to download to your computer to do it. Yeah. Okay. So for this one right here, I use the law of cosine and I calculate it on Excel and I choose there's some pair nice because it doesn't fit to my screen. So I didn't have much on my app, but if you can, if you want the whole set, then you can email me and I can give you the one. And I like to give my students smaller number. I don't like to give them too big. So it make it like a, the concept, we want them to learn the concept. We don't want to them to labor with the arithmetic. So I give them smaller number. So here, if you click on here, integer triangles right here. So this one right here, it have three integer side, 5, 7, and 8. And then you ask them to find angle C. So this one would be, angle C would be integer, the answer. D2 would be not nice. You use the law of sine, you find out it's not nice. But use the law of cosine, you ask them to, this setup, you ask them to find angle C, then the answer would be 60. I have a whole bunch of 60 degree right here. So this is another 160 degree for angle C. 3, 7, 8, and then this one here, because the screen, so I cannot make it bigger, so I want to see, so easier to write test. You can change the name. Instead of ABC, you can change it to RQT, SQR, whatever you want to, but keep this order. Then you will have integer side with 1 angles, integer degree. And then I have another one that would be 60 degree, 120 degree right here. So 357. I give you the answer of the other angle too, if you want to ask your student about that. Another 120. And then sum of 90. So I have in here, all that part. Let me see the. Yeah, you can use it for a trick. So I have a lot of things on apps. So towards the end, I will show you some app for the trick if we have time at the end. Yeah. And then we go to I don't know if that's is that your college? Any of you teach linear algebra? I think it's a few of college in here. They offer linear algebra or differential equation, all of that. So I'm teaching it right now. So I've been using this one since I taught linear algebra a couple years ago. So that's why I built this one here. So eigenvector, eigenvalues, these things it come out like not nice number, and it's not up to your head, cannot make up. And this level somehow in the textbook they don't care that you throw out whatever number that would be, assuming that our student master in all the arithmetic and other part. But I think the concept is it's hard. So give the student something like this, so help them to see. So we start with 2 by 2 matrix. Let me see if one more. So I have the characteristic of the eigenvalue equation this way right here. And then we plug it back, and then again, we solve for lambda. So lambda equal to a plus d, and then the part here. So I have d equal to this form. Again, you see that Pythagorean triple come back again. So we would use this Pythagorean triple. Let's see. Oh, okay. Clifton, I answer your question later. Okay, give me 1 minute. Where do I go to my things? So we see this one at Pythagorean triple again over here. So I'm gonna use Pythagorean triple formula to set up that. So a minus d equal to n plus 1. And then from here, I solve for a in term of d and n. For b would be my second leg. So I have this part right here. So I can drop down the 4. So I have b and c in this way. So from that, I can solve for d. I plug it back here. Oh, I think I should solve for d over here and not solve for n. I solve for d right here. Then I will have b and c in this way. So given 2 number a and n, and then I set up my d this way, my b this way, and my c this way. Then I will have my 2 eigenvalues in the form here. They are integer. So it's right down this way for you to see. So you can set up your eigenvalue I'm sorry, your matrix this way, then you have the eigenvalue and then you can compute your eigenvector too. So if my A equal to negative n squared or A equal this part, then I will have the 0 eigenvalue. So you don't want to do this when you're programming, you avoid this case. For 3 by 3 matrix, it would be harder to find out. With this setup, I like to give my students a smaller number. I don't want them try the big one. So make it like hard to follow, so we can do this part. So over here, I will have P and Q, D2 equals 0. Then my matrix becomes to this part right here. So you can see that if you compute a determinant, it's just gonna be S and you time with this one here only. So therefore my characteristic equation you have right here, so S minus lambda, and this part here is same thing with the eigenvalue that I have on the previous section. Right? I mean on the 2 by 2. So therefore I can use the whatever I learned from that one. So my eigenvalue for this small matrix right here, that 2 by 2 matrix right here, I can inherit that, and then I can use this part right here. So therefore, my eigenvalue would be S, and this one, I took it from the previous one. Yeah, so that would be my eigenvalue I have in there. So with this setup, I can compute my eigenvector. So I will have over here with S, then my eigenvector would be 1, 0, 0, and for A plus 2n squared would be right here. And for the last one, eigenvalue would be in this form. So you can program in this way too, to have that part. We have another form right here. All of them are integer, but you see it here, 0 right here. If you set up this way, then become that. If you take a look at the determinant of this one, it's nothing more, it's just the diagonal only. So it look like the diagonal matrix. So therefore, the characteristic equation of this one would become, just look at the diagonal only. So you have that would be your eigen value. So this is easy to set up that way. And so I have my eigenvalues are S, A, and D. So with that, I can have my eigenvector corresponding to this here. If S, then I have this eigenvalue. And A, I have this eigenvalue. And D, I have this eigenvalue right here. I think, yeah, I have that one in there. Corresponding for that part. So here is my app for eigenvalue. Integer eigenvalue right here, and you click on this. This one a little bit hard to read because this one it work only on the they call the CAD GeoGebra only. So I cannot do it on my desktop. It doesn't have this version, so I have to use online. So that's why the setup is kind of hard to read right here. So remember that my formula, it depends on my N and my A right here. This K is just for this matrix B right here. So if I change my N right here, you will see the matrix A changing right here. Right? And also matrix B change because B it depend on that part, okay? Matrix C is another way that I have depend on, okay, to another formula that I use. So I didn't write the whole thing on this slideshow, but on my paper, it were submitted on AMATYC, so probably come out next year. I wrote a paper about integer eigenvalue, you know, the relationship between Pythagorean triple and eigenvalue in there. So you will see this paper come out, I think next year sometime. Then you have this part and you change this here, so you can have all this here. So this is matrix A and eigenvalue of A right here, eigenvalue of B for right here, 0 here, and the eigenvector for A right here. I didn't show eigenvector for B and C. Maybe later I will update more for that part. And for the 3 by 3 matrix, so I have this one right here. So you have a whole bunch of them. So the matrix D, again, it depends on N, A, and S. So the 3 numbers matter. The other part, I should change things right here, have another formula to do. So I have 2 forms. So I have this, yes. So you can see that. Matrix D is the eigenvector that you see right there. Or you can change A, and you can have your things that go this way, or S. So each time you change. So you can have the eigenvalue and eigenvector right there. You can do that. This one for diagonalize, so another kind of related to eigenvalue, eigenvector for that part. So I use for, so you can look at later. And so that's it all for my for my integer solution. So again, all this app here, you can go to fanyamada.weebly.com and then click on teaching and math for elementary teachers, school teacher, and equation for integer solutions. So you have here. So I go it again. So for those of you missing on the first time, so you click on my website, and then here is you go to teaching, and then on this you go to math for elementary and middle school teacher, and click on here. So I give my student this. I ask them to write down the equation. Well, I try to hide it as much as possible in here. Then have other thing too. I didn't have time to go today, but you will find everything like that in there. Okay. Now I have some time. Let me see. Let me answer the question first before.
Okay. Did you see Martin's question?
Yeah. No, I didn't write out this one yet, Martin. I saw people wrote this part, but I didn't write out yet. So probably my next project, I will do that part. Yeah.
And for those in attendance, Martin sent his question just to the panelists. His question was, do you connect this to a visualization of eigenvectors? Okay.
Yeah, if you use GeoGebra, you go there, you type in eigenvalue and eigenvector. They have some of them in there too. So probably I will link those to my site so you can see it later. Or maybe if I have time later, I will write an app for that part too.
Okay. And let's see, Clifton, you had a question earlier. Do you mind putting that in the chat so everyone can see your question? And then it was about a tool for geometry. So.
Oh, the tool for geometry of
yeah, it's in the chat now. The question.
Yeah, yeah. I have the I didn't write down that one, but you search it on GeoGebra, then you will see a lot of them. They have the kind of show how the linear trilinear system work. we have one solution, and we have no solution. We have infinitely many solutions. They have indexed a lot. I wrote the 3D one, but the 3D I wrote is I use is more for curve than the other. Let me go one more statistics, and then I come back to I show you what do I do with 3D for you to see. Okay. Now, if you're teaching statistics, teaching in class is okay, but you're teaching online, it's kind of hard to show your student how to use all the apps. So statistics is not nice. The number is messy. You cannot have integer. It doesn't. I mean, it's real number out there. It doesn't have nice number. It's always messy. I mean, the result come out messy. So you can use my app. So you can click on this side, or same thing. You go to. Let me go with you again. Find Yamada. Go back. You can go to findyamada.whibley.com right here. Yeah. And then you go to teaching. And then you go to statistics right here. And here I have a whole bunch of apps and projects. Some of them I wrote, some of them I copied from other. So I linked right there to use in my class. So you will click on GeoGebra hypothesis testing app right here. So this one is like it have everything that I use in my class. It have critical value, graphing the different confidence interval, and then z-test, c-test, all kind. But this one here I use mainly, I post this one on Canvas, and I use this one for all my courses. I mean, from beginning to the end, I have it here. So this part is spreadsheet right here. And this one like graphing calculator you have in here. So you can have, if I scroll down a bit here, you can see binomial distribution, or you can choose normal distribution. So in here, you can have your student give mu and number and find out everything you have here. Another topic we use that would be the binomial distribution, which we cover in several classes. So you have in here. And you ask the student, okay, so if I have 20 people, and I throw the coin 20 times, so what is probability that I will have, 6 head, or between more than 5 head, or anything like that? So we'll show you right here. So let's see, I will have probability that I have 5 or less. Then it will show you the answer in here that you can see. Let me see if I can move this one here. Yeah. So it will show you right here that you have everything in here for statistics. And then this one right here, you can use z-test for the mean. So you can have, let's say this one would be equal to, let's say 100. And then I will use this one with less than, and then my sample mean, let's say, make it this one is like 95. And my standard deviation, just make up this one, for example, 15. And then my n, make it like 40. And then you can have here p-value, t-value right here. Then you have z-value, p-value you have here. They have all the f you have in here. T-test for the mean, you can use that one. They have the estimate the mean, the confidence interval you have in there. They give you here upper limit, lower limits, and all the things that you have in here. Or they have good net effect that you have in here. You can type in observation number and then expected count, and then you can do that part. Or you have chi-square test you have in here. So you have all the number that you can change this one too. Now, if you have data, then you can, so let me exit out. If you have data, you post the data here, and then they can do the test on here too. So for example, I do this one. I use t-test for 2 samples, for example. Then I choose this one right here. I go to down. maybe let me bring this one up a little bit so you can see. So I'm going to choose t-test for different mean, so that I can have right here. Or so you have the value, everything is show up in here if you highlight this. So this calculator will talk to this data and they have everything you have in there. So that is for statistics you can use in there. Okay, so let me go back to my page. I show you the graphing that I have.
We have about 10 more minutes.
Yeah, just the quick thing to show you derivative integrations, all the graph we have in here. So let's see a sequence, you have more in here, I have in there. So this is derivative, and then you can use the epsilon delta that you have in here. You have a lot to show you some of them over here. So this one kind of, you click on, you choose the point, and then you choose your delta. I can change my Y right here, big or small. I can move my point right here. See, I move my point, I can change it to see that. And I can choose my epsilon. So this part here to show you. Let me show you my trick class. Oh, it's just here, this one right here. Oh, I'm sorry, the wrong one. So this is for trick. So you can use, for this one you have here, you can move, you can change the things, the trick you have in there. So go back to my website, you can explore. I ran out of time, but if you go back there, you see several topics that I have in here using GeoGebra a lot. So let me go answer your question in here. I didn't, oh, thank you, Martin. I will search for your app in there. So see the mapping. I didn't do much mapping in GeoGebra much. Most of my time is to, my thing is do something like you see right here. You will see that one in there. So, but I will check out your website, your GeoGebra, and then copy some of your your app, put in there. Thank you for sharing. Yes, you have 3D in there. So let me, give me 1 minute. Let me pull, I show you one of my 3D work I have in here. Let's see. This one is from my paper that I published. It was published last month in April, I think. So I have, let's see. Sorry.
while you're looking for that, we got a question here.
Yeah.
It's actually not for you.
Okay.
Martin, I don't know if you saw this in the chat, but somebody asked, would you be willing to share your visualization tool with the attendees? If so, if you want to just send it to me, I can share it with the list of people who signed up for today. So we had that question. We got just about 5 more minutes.
Yeah, give me, I couldn't find this, my things in here. I think I have to search for. Yeah, I don't know. I couldn't. Give me. I couldn't find it where, but can you like email me one, and then I will send you what I have in there. I didn't prepare for this, so I don't have it here. But could you please email me at Tifanyamada, this one easier, Yahoo. Then I will send you what you need in there. Thank you. I will flash this one here so I can do this one here. Yes, thank you. And I would like to, I have this one Martin, so we can look at it later. I like to promote, so kind of another follow-up talk for this one here. So I show you the math behind all of this one. So now we're gonna write question bank, and I use my open math to write this question bank right here. So if you are interested to do this one, then you can, my talk will be on July 22nd. On the topic is randomized question to avoid cheating, hosted by Women in Mathematics. So you can email Shana Adoption right here, and then she will send you the link for my talk on July 22nd about randomized questions to avoid cheating. So that's one. So she will send you the link for that part. So I will ask her to post on the website if you want to join in with me on the talk. So thank you so much for joining me today. And any question, please email me.
Okay, if we could thank Tia Dong in the chat with a kind word or two. While she does that, I'm going to stop your sharing and put the rest of my files up. Oops. Okay, so thank you for participating in today's webinar. If you're not a member, we would love to have you join. We do have a presence on Facebook, so you can search Facebook for AMATYC. There are other professional development opportunities coming up, including conventions in Spokane this year. Hopefully we can still do that, and Phoenix next year. We have more webinars coming up along with traveling workshops. We'll try to get the materials from today sent to you as soon as possible. It may take up to a week or two, but hopefully a day or two. And then for those who want to evaluate this session, the link is there, or the QR code, and I will put the link up in the chat here in just a second so I can take this down. But Tia Dawn, thank you again. This is 2 summers in a row. You've done a very nice webinar. It was very well attended, a lot of good comments. For those that didn't see it, Martin did post a link to his website in the chat if you want to get some more of his materials. And I think that's all. Thank you all for attending. I'm going to stop the recording now.